morning, everyone. I'm Missin, and I'm actually working for the City of Zürich, so public organization again. And at the same time, I'm doing my PhD at the Loughborough University under the supervision. Oh, thank you. Not sure I'm going to need it because normally I'm the kind of speaker that screams a lot. So let me put it this way. There we go. Yes, and the topic of today is a comparative analysis between digital twin and BIM as a technology foundation going towards automated compliance checking and looking beyond that. Before we dive into technicality, let's go back a little bit in the story. What is or why do we need compliance? The first question that we need to ask, because we've been trying to solve problems or automated things that we're already doing now manually, and that is not the goal that we should be looking at forward. So every code actually tells a story about a disaster that happens, and the code is actually the mitigation for the future. So if we look at it historically, every code that has been created is created to mitigate a solution that already happened. It means that we accept that we're gonna do a mistake. Moving from the historical background and looking at the logic, there are three principles that actually support why we do compliance checking or construction permit. The first of all is to mitigate harm principle. Second one, reduce cost. And thirdly, and really importantly, find the right responsible for whatever risk that we're taking. Supposedly, somebody is building, a client is ordering for a building, and a contractor provides the building. The one that the client actually cannot technically make sure that the building can stand. That's the reason why we have compliance experts that actually look into it. It's really important that I rephrase it now because it asks the question, if we have now the technology, shall we use the technology to actually assume every time that we start a new planning that we're definitely gonna make mistake, and then we're just trying to work on those mistakes, whereas we could actually ask the right problem. Can we avoid the mistake, right? So that leads to actually my to this first part of the research, which is actually what is manual compliance checking. Nowadays, we're doing manual compliance checking a lot. It has moved to a solution where we have like rule-based compliance checking with different software, you know it, Solibri, BIM Collab, Zoom, and everything. And the question is, what is the way forward if we look at it, right? We're going from a manual task that is really error-prone because whenever we're correcting a mistake, we're creating another one, to a rule-based that actually only translate what we were doing manually. And we're looking at the future, since we have already generative technology, if we can use it to actually make the process slimmer, the process leaner, and the process more intelligent, right? So for that, the actual question for this SLR is which technology foundation and which combination of AI technique can help us actually advance or extend or automatic compliance checking, and maybe looking into a generative solution. For that, I did a systematic literature review. I'm not going to lead you through the whole thing because every one of you is well versed in the Prisma process. Going from 2,300 papers, I streamlined it to 141 unique entries, which actually build the foundation for my analysis. And to go into that, because we need now that we have the data to interrogate the data, we need to ask the question, what are the methods that we're gonna use? For me, the first one was actually a bibliometric analysis to be able to tell the story of the evolution of those research. The second part is deductive analysis using keyword analysis, so first viewer, and an inductive way with an AI-assisted thematic synthesis. So those are the three things that I did, and at the end, we're gonna see like a synthesis of what the story the paper are telling us, right? So first of all, looking at our substract or yes, of the corpus, if we look at the maturity or the amount of paper published between 2018 and 2026, we see that BIM and ACC is the much mature corpus, because it peaked at 2022 with above around 25 paper published on the topic of BIM and AEC. I'm specific about it. Compared to it, the digital twin and ACC is more like an emergent frontier, with first paper in 2020 and going a little bit further 2025. So you see at this asymmetry, the more mature substrate, and in this case BIM, has behaved as a mature substrate, and digital twin and AR and ACC are actually more the emerging frontier. But looking at the numbers of paper that we have, it doesn't build actually a solid corpus for quantitative good analysis or comparative analysis. But we're going to use that as a departure. Based on that, the keyword analysis show us actually that building information modeling is still the central frontier. If we look at the occurrence and the total link strength that I propose, we can identify about 5 core that actually represented: building information modeling, automatic compliance checking, and there is a good reason why I separate the two, because here we're talking about rule-based, and here we're talking about manual. Digital twin and IFC semantic web interoperability. To synthesize it, because I like to make things look even simpler than they are, I move it to a simplistic overview where we have actually 4 core that are represented. The central core is BIM as a foundation data paradigm, even if we consider digital twin as the extension. Automated code compliance, that is actually being a topic of research with the latest development and maybe a future expansion. Semantic web as a way to look at data and maybe find a way to reuse the data, and digital twin as the emerging frontier, because now we're talking about interaction between real world and virtual world. And the really important observation here is that there is no direct occurrence between digital twin and ACC. It means that nowadays, if we look at it, there is actually no research that is focused on digital twin and ACC. That is the first remark that we can pull out of this visualization. Looking at the temporal overlay, we can see that we have three epochs that emerge: 2021 to 2022, where automatic compliance or rule checking, automatic compliance checking were more in the focus. 2023 or 2022 to 2023 with more intense research on associating ACC and BIM, and 2024 and 2025 with the emergence of AI technology implementation within the built environment and digital twin. Moving from that, we can actually see that those 3 epochs are interlinked with each other with different strength of connection, which confirm the first assumption. And here we can directly see that there is still no link in between digital twin and ACC. On the thematical pillar, here I went through the papers to actually not only look at the numbers, but look at what the papers are telling us. The papers here tell a story about what are the core thematic that are being handled in the sense of ACC, going from the method, the information analysis with different type of ontologies and knowledge graphs, the methodology to actually harness the information within the informations, and the different uses of the information. We're talking about here lifecycle application or digital twin and blockchain into the application, the project that are actually being tested. And we have the last pillar that shows us the technical challenge that ACC are facing. And one of the really interesting part is even on the thematical level, which meaning exactly the citation of the paper, we still have digital twin and ACC integration that is not yet operable. So we're talking here on the level of mostly theoretical framework, no prototype developed, and obviously no artifact developed, right? So if we go now in the interpretation, and now I'm talking about my vision of the data, we can see here, first of all, that BIM is mostly involved into the design and construction and less in post-construction and demolition. And if we look at relative numbers, it feels like digital twin is have a better coverage on the life cycle perspective. But on absolute number, we can see here that BIM is actually quite well represented, and digital twin is really the emerging frontier in terms of compliance checking within the construction, which pushes to a next representation. And this representation tells us how much, what is the maturity of development of ACC within those different topics, looking at design, construction, pre-construction, and demolition. And we can see here that on the cross stream, so BIM and digital twin together, there's literally no artifact developed up till today. That is what the data are telling us. And in terms of maturity, which means actually artifact developed for ACC with different foundation, technology foundation exactly, BIM is the more mature substrate. So here with different prototypes that actually propose and different direction for further development, right? So these links to actually three independent observations. The first one is the K network telling us there is no direct link between digital twin and compliance checking. The thematical map confirms it, and the maturity matrix tells us validate actually those observations. It brings to one big gap, the first one, that tells the principal research gap here is actually digital twin and ACC for the future. Problem is digital twin is not a mature substrate to base our future development, because digital twin in the construction field, in the construction environment, is a frontier that still needs to be tested, developed, and actually analyzed, right? Besides this one gap, there are three other gaps that actually emerge. The first one applies to semantic technology. So here we're looking at LLMs applied to ACC. And it's really important here to mention we have developed different development. NLP-based development, ontology-based, and what was it? AI-based. And those three actually are parallel streams that are being followed in the research. But there is no merger or no hybrid architecture that maps actually NLP, ontologies, and so on, right? The real-time operational compliance is actually what we're trying to now do, considering IoT on the construction field, which maps into the first gap that was presented. And the last one is the methodological cluster. So we're looking at what are the different approaches that can be actually implemented. This tells us, first of all, design stage BIM is the mature substrate that we're looking at right now for an ACC and AI implementation when we move to a generative part. Moving to a generative part means actually we're not looking at the standard way compliance checking we're used to make. Let me go back a little bit because it's important that I mention it with the right figure. If you look at the pillar number 1, ACC is defined in 4 steps. First of all, the rule interpretation. Secondly, the model preparation. Third, the test. And the fourth, the reporting. So at the end of compliance check, what we expect is nowadays a report of the mistake and what we need to fix, with who is responsible for fixing it. Nowadays, if we look at a more generative way of, so we're not going to be looking at the rule sets as a way to, as a finish, as an output, but the rules are gonna be the actually input to go onto generating compliant model for the future. So what are we looking at? We have the set of rules nowadays still existing that define the regulatory constraint. Then we have a prior model, or the sketches that represent what the designer actually proposed and what has to stay consistent, right? Next part is afterward the verification, and the verification, which gives us the diagnosis, tells us what needs to be fixed to be compliant. But now we're gonna use these three as an entry to go into a generative part. So this is gonna help us to have to synthesize what is actually missing into the model and generate compliant candidates. And that is that is my thesis right now, that we can change the perspective of how we're looking at ACC from a responsive process to more of a generative process, to actually reduce the manpower and the resources and the error phase that happens when we go into quality management into directly going to compliance model, right? So the verification here is reposition that you see, and it's not actually the end output, but actually one of the inputs to go into our generative constraint. To sum it up, BIM constitutes the mature substrate. Digital twin is the one horizon, the frontier horizon that needs to be researched but not mature yet. So it's for further, for a later horizon. The unoperarized DT ACC link is one of the points that still need to be looked into. And when we talk about generative AI, we actually look at NLP, in general, AIs and ontologies development that can actually be brought together to generate models instead of correct models. With this, I'm at the end of my presentation. Thank you very much for your attention.